So remember that this lab is all about calculating the equilibrium constant for this reaction. So that's the main overall goal, is to calculate the equilibrium constant. Now remember, the equation or the system you're dealing with is iron 3 plus and the thiocyanate ion, SCN minus 1. And so that sets up an equilibrium system, and it makes this FeSCN minus 2. Does that look like the reaction that's on the front of your lab? Is that the right reaction? Oh, plus 2. Sorry. Is that better? Okay. Just checking. Now, what you did last week was you prepared a series of, because this is red, we can use the colorimeter to measure concentration, right? So last week you did this. You prepared a series of concentrations where you mixed a lot of this that was a point, was it 0.2 molar in concentration, with this that was 0.002. Do I have the right number of zeros on both of those? Or was it something a little different? Is that right? So notice that the iron is so concentrated that it's going to drive this reaction far to the right. And so what we said was, in that series of reactions you did last week, you had like 1, 2, 3, 4 different amounts of this that you mixed in. And for each one of those, you had to calculate moles per liter, moles per liter, moles per liter, moles per liter. You calculated that concentration for each of those of the thiocyanate ion, but because the iron ion was so concentrated, the molarity that you calculated for thiocyanate was equal to the concentration of the iron thiocyanate, because all of this turned into this because we pushed the reaction to the right with this really high concentration of iron. Remember that from last week? And then you collected data points, and hopefully somewhere you have data, or you maybe even have a graph, so that from the information you have last week, you can measure the absorbance of any iron thiocyanate solution. And let's see, you measured absorbance, and down here you're graphing concentration, and you should get a line of best fit that's hopefully pretty close to all your data points, something like that. So that for any absorbance you measure, say you stick it in the colorimeter and you get this absorbance right here, well, you can either use the graph, or maybe even better, you can use the equation for the line, and you can calculate whatever this concentration is right here. So that's a calibration curve that you made last week. And part 2 of the lab, if you're looking at the procedures there in part 2, the big idea for there is just to check your skills. Can you measure the absorbance of an unknown concentration of iron thiocyanate and measure, find its concentration using this method? That's all part 2 is. Part 2 isn't a big, huge deal, not huge amounts of calculations, maybe a few, but nothing like part 3. So I don't know, have any of you done part 2? Okay. I didn't think we had gotten that far last week, but I just thought we'd check. Okay. So let's move on to talk about part 3 for a moment. Part 3. In part 3, you're going to collect data to actually find the equilibrium constant. And remember, your equation is Fe3+. You've already got this. We're almost getting to the point, though, that you may want to jot down the icebox for this, because the icebox is going to be important to you. And if you would look at your data table, or the table where it tells you how to mix these up, because I don't have that right in front of me, and I'm going to need some numbers from you to help with that. The milliliters, yeah. Okay, so what we're going to do here is, what they're asking you to do is 4 different experiments. And for each experiment, you're going to have to go through this series of calculations. And for each of those, you're going to need, you don't know Kc, you're going to need the concentration of FeSCN, and you're going to need the concentration of iron at equilibrium, the iron-III ion, at equilibrium, and you're going to need the concentration of the thiocyanate ion. You're going to need all of those at equilibrium. So let's just look at, what is it, test tube 1? How many milliliters? I'm going to put a line here on my icebox. This is my initial, and then I'm going to do change. I'm not going to need a very big space for change, and then equilibrium. Okay, so for the iron ion, what's the concentration we're using? 0.0020 molar. That's the stuff we're initially mixing in, and then what's the initial volume? 3 milliliters. How many milliliters? 3. Okay, 3. And I'm just going to write 3 to save space. Not going to put the right number of sig figs. So that's the initial volume of the 0.002 molar iron. But we're actually going to dilute it, right? Because we're mixing it with some other things. So we're going to dilute it to, is it 10 milliliters altogether? If you add up all the milliliters across that row, how many milliliters? Is it 10? So we want to find our final concentration when we've diluted this to 10 milliliters. That initial concentration, let's just calculate that real quickly. One of you guys have your calculator handy? There's one. So we do 0.002 times 3 divided by 10, and I get 6 times 10 to the negative 4. And to get the right number of sig figs back in here, that's probably 6.0 times 10 to the negative 4. That's the initial molarity of the iron. Did you follow how we got that? So that may be the same for the initial molarity of the iron in each of your tests today, of your 4 tests. Is that right? Do they use the same volume all the way down that column? Oh, that was easy. We just did one big set of calculations. What's the What's the initial concentration of the thiocyanate? Correct me if I'm wrong. Is it 0.002 molar as well? Okay. And in test tube 1, what is the concentration? What's the volume we're using? 2 milliliters. And we want to find C2, and we're diluting it to 10 milliliters, right? So to get C2 in this case, I'm going to do 0.002 times 2 milliliters divided by 10, the total volume, and I get 4.0 times 10 to the negative 4. Does that look right to everybody? That's the initial concentration. What's the initial concentration of the iron thiocyanate when you first mix these two things together? 0. Oh, that makes it easier. That makes our math a lot easier. So which direction is this reaction going to go? To the right. In fact, it's going to add X to this. It's going to subtract X from this. And it's going to subtract X from this. So when you're working on the lab today, what is it you're going to measure? Well, you're measuring, based on this, you're making a calibration curve like this, you're measuring the concentration of the iron thiocyanate. Let's see. You're measuring the concentration of this at equilibrium. So really, what you are finding when you measure that is you're finding X. You're finding the concentration of the iron thiocyanate ion after it comes to equilibrium, and that is X. Now, to find the concentration of the thiocyanate ion, you're going to be taking in this particular experiment, you'll be doing 4.0 times 10 to the negative 4 molar minus X. And to get the concentration of the iron ion, you'll do 6.0 times 10 to the negative 4 molar minus X. And at that point, you'll have the equilibrium concentrations of everything. Because you know what X is, you can calculate the other two concentrations, so now you can find the equilibrium constant. So you'll find that 4 times, different concentrations every time, but you'll calculate the equilibrium constant. And in the data yesterday, this worked pretty well. People who were careful were getting numbers that were within, probably within 3% of each other. I think all of their numbers that I saw yesterday, the measurements were within 3% of the same value for the equilibrium constant. And so they just average those together and come up with the equilibrium constant. So there's going to be a lot of calculations for you to show. And going to encourage you to show those neatly in your lab book. Some of you are just going to do a rough draft and then recopy it into your lab book. Some of you are going to put it in the lab book as you're working. Either way, that's okay. Can you think of any questions? What? X is what you're going to measure when you measure the absorbance in the colorimeter. So you'll have a colored solution. You'll measure its absorbance, and then you'll go back to your calibration curve that from your data from last week, and you go, oh, that absorbance was right here. And so the concentration, you calculate it probably with the line equation, and you'll go, oh, that concentration is right here, and that's how you find X. And that concentration should be different for each of your 4 experiments because you're starting with a different set of equilibrium are a different set of concentrations of the iron and thiocyanate ions.